So we shall have this, the 3 out of 5 goes inside. We shall have 2 to the power 5 times 3 out of 5 inside, divided by x power half equals to 2. Now this and this will cancel. We shall be left with 2 to the power 3 divided by x power half equals to 2. 2 to the power 3 is the same as 8. Now here we have something like this. This is 2 to the power 3 divided by this. Let's write like this so that we visualize it well. X power half is equal to 2. What do we do from here? We can say out of 1 and we cross multiply because our unknown that we're looking for is the denominator. So to take it up, we cross multiply here. We shall have 2 to the power 3 times 1 equals to 2 times x power half. That's what we have. Then, of course, this 2 to the power 3 is the same as 8. We can take it 8 straightforward equals to 2 x power half. What do we do next? We remove the 2, divide by 2 here, divide by 2 there. This and this will cancel. My x power half is the same as 4. Now, what do we do here? What do you do next? Who can tell us what do you do next? What do we do next here to get the value of x? Yes? Who can tell us what we do?
We get the square root of 4.
We get the square root of 4, yes, because x, we get the square root of 4. Is x
We get the square of 4.
The square of 4, yes. This is equals to 4. Now to remove this half, we square both sides. Square this way and also square the other side. That this one and that one will cancel and remain with x equals to 4 squared and x will be equal to 16. That's what we do. Or we can say, just like we looked at this the other time. We said that x power half in indices equals to 4. This is the same as writing the square root of x equals to 4. Remember that? We said when you have a fractional power like this, the denominator shows you the kind of root you're supposed to have. If it is 3, if you have a third here, then that would mean that you're getting the cube root. If you have 4 here, then you're getting the 4th root. Then the numerator is the power always. I can say, now this is the power 1, like that, because the numerator is 1. If it was 2, then it would be power 2. So if I have the square root of x equals to 4, to get rid of the square root, I square both sides. Square here, square here. So this and this will cancel. Now x equals to 16. Just like we did here. When you square, this and this will cancel. So that's what you're supposed to do in the exercise. If for those who did it, the correct answer is supposed to be that one. Then lastly, this one, we are now 44, the numbers increased. We're almost getting there. When you clock 50, we shall switch to logarithms. So here all you do is prime factorize everything. 32 should be prime factorized, 8 should be prime factorized, 4 should be prime factorized. Then you continue. 32 is the same as 2 to the power of 5. 8 is the same as 2 cubed. And 4 is the same as 2 squared. So we substitute in. This will be 2 to the power 5 into x times 1 out of 2 to the power of 3 times 2 to the power of 2 into the other power is x plus 3, like that, equals to 2 to the power 24. You don't prime factorize 24 because it's an index. You prime factorize bases. You prime factorize bases, but not powers. So what we have here, the 5 and this will multiply, you have 2 to the power 5x times 1 out of 2 to the power 3. This will be times 2, this and this will multiply. We shall have 2 multiplying with x plus 3, like that, equals to 2 to the power 24. So from here on, you'll have 2 to the power 5x times 1 out of 2 to the power 3 times 2 to the power 2x plus 6, 2x plus 6 equals to 2 to the power 24, like that. So from here, then now you apply the laws of indices. This is multiplying with this, so you're going to add their powers, dividing by that, you subtract that power. So you shall have 2 power 5x. The connection between this and this is multiplication, so I'll say plus 2x plus 6, you see, because I'm multiplying this, I'm adding the indices. Remember those laws that we looked at. So here I'm multiplying, add the index, we have that, indices. Then here, you subtract the 3 since it is down. This is 2, this is 2, this are two same bases, so just deal with their powers. Minus 3 like that. Equals to 2 power 24 like that. So this one here, we shall have 5x plus 2x 7x 2 to the power 7x plus 3 equals to 2 to the power 24. Then here you do what? The powers. You equate the powers since the bases are the same. We shall have 7x plus 3 equals 24. Then take 3 the other side. We shall have 7x equals 24 minus 3. Then we end up with 7x equals 21. And lastly, divide by 7, divide by 7. We shall end up with x equals to 3. And there you'll have solved. That's what you're supposed to do in the previous, that exercise that you're supposed to look at. So this marks the end of indices. That's the end of indices. All you have to do is you should practice these indices, do more questions. I'll send you the video and some write-up of it so that you can enter some things in your notebooks. So let's switch over to logarithms, but this is what we've been looking at all along. You can see we've done a lot. We've done a lot of time. A lot of work. We've spent a lot of time on indices, and now you need to practice. Of course, mathematics, if you don't practice, you forget. So make sure you practice these things. Practice from time to time. Okay, logarithm is what you're supposed to look at now. Logarithm is not very different from indices. In fact, logarithms are just a special type of indices, special type of powers, but they are related. No? The same thing almost. Let me zoom it in. Yes, hello.
So we meet each other.
Yes, please.
Should be right. Should be right.
No, I think I'll send you the work to write. You should not write. You should not write. Just note down a few things. You should not write because that will take you some time. Just note down a few things, but basically pay attention. Pay attention, note down key concepts that when I send you the work, you can recall what. So we are saying logarithm. What are logarithms? In the definition here, we're saying a logarithm is an index. And of course, we just looked at indices. A logarithm is an index, exponent, or a power. The logarithm of a positive number p, let's pay attention to this. The logarithm of positive quantity p or positive number p to a given base q is defined as the index or the power to which q must be raised to make it equal to p. Now this is what we have. Look at this. We have p, we have q. We have p and q. Now if you're finding logarithm of p, to base q. If you write logarithm of p to base q, you're simply looking for the index, the power, this index here x. You're looking for the value that you should raise q2. This x here, which you call the index, which is the power, is also sometimes called the logarithm. We've just looked at indices. So this x here is what we call the logarithm. So you can write below it, we can write here something and say, where, you can write here and say where, this is too big. You can write here and say where, okay, where q is the base, q is the base.
I can't hear you.
You can't? You can't do what? You can't see what I'm writing? Okay, let me put it right here. Go to view and reduce. So you can say where, I think you can now see this, where q is the base, q is the base, here this q is the base, and you can see that. Then x is the index, and we've seen that. It is also called, sometimes it is called the power, we know that. And the other term we're introducing, it is also called the logarithm.
Excuse me, sir.
Yes? Yes, please. Hello? You excuse, but I'm not hearing you. Can you just send me the message? Just send me, inbox me. Sorry?
You're cracking.
My?
You're cracking, teacher.
I'm cracking?
No. No. No, you're not cracking.
Pass might be on connection.
Maybe the network. And P is a number whose logarithm is x. Now, when you're writing this in logarithm notation, if you're writing, they ask you to write this in logarithm notation. This is how we write it. We shall say, here we're saying q, we are saying q to the power of x is the same as p. And in the definition of logarithm, we're saying, if you're writing the logarithm of p to a base q, logarithm of p to base q is defined as the index or the power to which q must be raised, that is equals to p. Now, if I have this, we can write this one in terms of logarithms. This is in index notation. We can write this in logarithm as logarithm, where you just write log of p. We're looking for the logarithm. Let me get the thing here. We can write this as log of p to base q equals to x. This one is in index notation, this one is in logarithm notation. We are simply saying that q to the power of x, q to the power of x is equals to p. That's what we're saying. This statement here, if you can write this one in words, we're simply saying q to power of x to power x is equal to q, is equals to p, something like that. Now you have your calculators there. I want you to, if you have a calculator, I want you to carry out, do some things here for me, and we see what you're talking about. We try to visualize what you're talking about. If you have a calculator, I want you to try out a few things here. Yes, somebody raised their hand. Desmond?
Teacher, I beg your pardon. I beg your pardon. The explanation of q to power x is equal to p. That explanation here.
Okay. So we are saying this is what we just learned. If you have p, it means, if, for instance, if this p is 4, we're simply saying that if I have 2 to power 2, this will give me 4, isn't it? Now, if you write this in logarithm notation, if you write this in terms of logarithm, you write it as logarithm of 4 to base 2 is the same as 2. When you write this in words, we're simply saying that 2 must be raised to a power of 2 to get 4. You see, 2 should be raised to power of 2 to get 4. The other example is when you have 10 squared. 10 squared is the same as what? 100. This is in index notation. How do you write this in terms of logarithms? We shall say log of 100 to base 2. I mean to base 10. Log of 100 to base 10 must give me 2. We're simply saying that to which power should I raise 10 to get 100? 10 to the power of 2 is the same as 100. 10 to the power of 2, which is the same as this. If you write index notation, we're saying 10 squared is equal to 100. That's why I said if you have q to the power of x is equals to p, we are simply saying that log, remember this is the base and it becomes a base, log of p to base q is the same as x. I'm simply saying that you should raise q to the power of x, that it becomes equal to p. I should raise 10 to the power of 2 to get 100. I should raise 2 to the power of 2 to get 4. Are you now following? Hello?
Yes.
So that's what logarithms are all about. That's what logarithms are all about. Let me give you another example. If they say, if you have 3 to power, then be 4 is equals to 81. This is index form. This is in indices, index form. Now in logarithm, how do you write this? We shall say logarithm of 81, which is the number whose log I'm looking for. Log of 81 to base 3. Here we're simply saying to which power should we raise 3 to get 81? Yes? To which power should I raise 3 to get 81? What will be the answer? 4. So here we're simply saying log of 81 base 3 is the same as 4. Log of 81 to base 3 is the same as 4. Now what about this? Log of maybe we can say 8 to base 2.
Beg your pardon.
Yes?
Beg your pardon, I understood that part there.
This part. So here we're trying to just make sense of the definition of logarithm. The definition says the logarithm of a positive number p to a given base q is defined as the index or the power to which q must be raised to make it equal to p. Something like that. So here we're saying if you find the question and you're having a statement like this, let me create more space. We need to understand this because it's now the logarithm itself. You don't understand the introduction, the definition of logarithm, things will be a bit challenging. So let's try to spend a lot of time in understanding what the definition is. Now we're saying if you have log of P base Q, if you have such a statement, mathematical statement, what does it mean? You're finding log of P to base Q. Log of P to base Q. We're simply saying here that if I get Q, of course Q is the base. If I get Q to the power of X, it will be equals to P. That means that Q, the power of X, is the same as P. That's what these two statements are equivalent to one another. They are the same. Q to the power of X is the same as P. I've given you an example here. Log of 4. Log of 4 to base 2 is the same as 2. Here we're simply saying, to which power should I raise 2 to be so that it is the same as 4? To which power should I raise Q? That's the same as P. We're saying X. So Q to the power of X will be the same as P. Here, 2 to the power of 2 will be the same as 4. Even here, I'm saying, to which power should I raise 10 to get 100? Which power should I raise 10 to get 100 is 2. So 10 to the power of 2 is 100. This is the index 4.
Are we writing?
Sorry? We are not writing. We're not writing. I'll send you the work to write. We should just pay attention. Just pay attention and make sure you understand. Writing, of course, you just write for the sake of trying to refer back to it and we recall. You didn't write indices. I'm going to send you that work, and that's when you write. I'll send you the video so that you can pause, write, watch the explanation, and understand everything afresh. But writing, when I'm explaining here, you know, online, we're there for a short time. We cannot waste our time again waiting for you to write, then you proceed. You can write when you're offline. I'll send you the video, you download it and copy it at your pace. So we have this. We're trying to make sense of the definition of logarithms. If they say log of P to base Q, they're simply asking you, find the power to which Q should be raised. That is equivalent to P. Log of 81 to base 3, they're simply asking you, to which power should 3 be raised? So that is the same as 81. Here, another one, let me see, did I give you another one? Let me give you another one here. Logarithm of, let's say, 25 base 5. What will be the answer? Yes, it will be
5.
5. Is that correct? Should we say 5 to power 5 is the same as 25?
2.
It is 2. The answer is 2 because 5 to the power of 2 gives me 25. So here the answer is 2 because they're asking you to which power should we raise 5 to get 25. So here we can even say 5 to the power of 2 is equals to 25. So you notice that that in logarithm we just a special case of indices here. So any questions so far before we proceed? Any questions here before we proceed? So far, we're just defining the term logarithm. We're saying the logarithm of a positive quantity or positive number P. Where we're saying positive, the number has to be positive always. P has to be positive. So the logarithm of a positive quantity P to a given base Q is defined as the index or the power to which Q must be raised to make it equal to P. Log of P base Q is X. We're simply saying Q to the power of X is equals to P. Yes, Mgaga, your hand is up.
Yes? So the fact about logarithms is the power which is used to raise it to make it to P equal to P.
Yeah, the power which is used to raise the base, so that is equals to the number. You make the base equal to the number whose log you're looking for, in simple terms. If
so the power is the answer.
the power is the answer, the power is the log, because you're defining the logarithm as an index. Logarithm is defined as an index, so the logarithm is the power in simple terms. Now in this case, the power here is 2. That means that 10 to the power of 2 is 100. So in this case, the logarithm is a 2. You get it? If I have 125 equals 5 cubed, in this case, the logarithm of 125 to base 5 is the same as 3. You get it? This can also be written as log of 125 to base 5 is equals to 3. We're simply saying 5 to the power of 3 is the same as 125. So this is the index form. This is what we've been looking at. Then this is in the logarithm form or logarithmic notation. Let's have all the questions, all the questions that you think, all the things that are still disturbing you here, so that we clear it before we proceed, before we dive into the details. Yes, please.
So what you're trying to say that the log is the index, and the part where there's Q is the
base.
So to get the log, you factorize the P by the factor by the base.
You're saying to get the log, you do what? Yeah, yeah, that's something like that also. If
you're saying to get the log.
Yeah, if I get your question, to get the log, you prime factorize the number, the number whose logarithm you're looking for. For instance, if they say find log of 8 to base 2, 8 to base 2, they're simply asking you to which power, to which index, to which exponent should we write 2? So that is equivalent to 8. What power should we raise these 2? So that we get 8. That's what they're asking you to do. Now here, I'll simply say, this is the same as 3. If I write 2, the power of 3, it will be the same as 8. That concept clear, Martin? Is it okay?
Yes, teacher.
Okay, all right. So let's proceed and see. That's the definition of logarithm, and we're going to use it from time to time. We're going to apply it everywhere. So make sure you put it at the back of your mind. We're going to refer to it every time. Okay, let's look at another thing here. Of course, we're defining something. Here we're saying where log is the abbreviation for logarithm, then the abbreviation for logarithm, then Q is the base, we call it the base, then X is the index. X is the index or the power or the exponent. You'll find it somewhere. This one also, exponent, and this another term is the logarithm, the new term we're looking at. So index is the same as the logarithm. Now, if you have a calculator there, let's see how we can get these logs on our calculators. Those who have calculators, can you look at your calculator? If you're seeing you have a calculator, there's a logarithm on it somewhere. Are you seeing that icon is log on it? That button is log on it. Are you seeing it?
Yes.
Yes, sir.
That's the button we use while looking for logarithms. Then also at a certain point, we shall have to use mathematical tables. I don't know whether I bought the tables. Did you?
I beg your pardon.
Sorry?
I
Pardon?
never saw where you pressed.
The button, eh? Hello?
Yes, yes.
Yeah, I'm going to show you. I'm going to show you that. Now we're saying, look at this note. Under this note, we're saying, of course, all logarithm will be written like this. Log, they give you log, maybe base q of p is equal to something. This is always the base. We've seen they can say log of 8 base. Bases can change. You can have base 2, you can have base 3, you can have 4, you can have any base. Now, this NB is saying, in this NB we are saying that unless the base is given, then we always consider our base to be a small base. It will always be base 10. When you find a number, some numbers will just write them like this. They'll say log, sorry, this is a highlighter. They'll simply say log of maybe 100.
Relax.
Can you pay attention? They'll simply say log of 100. In this case, they have not given you the base. So we're saying in questions where the base is not given, then always consider the base to be base 10. Not unless the base is given, it is taken to be base 10. So when you find a number like this one here, when they say log of 5, this log of 5 is the same as there's a base 10 there which has not been written. So whenever I find a number and the base has not been written, then take the base to be a decimal base. So this will be the same as when you find log of 5 and the base has not been written, this is simply the same as log, the base 10 of 5. You take it to be a decimal base. Even this one, log of 4. Log of 4 is the same as log of 4 to base 10, something like that. So whenever I find logs, whenever I find a log and the base has not been indicated, just know that you're dealing with a decimal base. Is that clear? Is that okay? Hello?
Yes.
Yeah.
Yes.
Yeah. So whenever I find,
Excuse me, teacher.
yes, please.
If you say that the base is 10, and if you say log 5, okay, that the base is 10, what will the answer be?
And this is what we're going to look at. Now here is a bit hard for us. We're simply asking ourselves, to which power should 10 be raised so that we get 5? To which power should we raise 10 so that we get 4? Now here we use our calculator. Let me show you how to use the calculator. So you look at your calculator, if you have a calculator there. This is my calculator. So I'll go to where log is. Log, this is the button for logarithm. It is here. I press log. And this is what will bring on my screen. Let me first clear. This is my screen. So I look for where logarithm is. Log is here. Where is it? Where is it? Where is it? No, I can't see it. It is here. So I press logarithm like that, and to bring something like that on my screen. That log on the calculator is in base 10 already. You know, it is already in a decimal base. So it is not in any other base. You can't use it to find log base 3. You can't use it to find log of base 2. It is always in base 10. So when I press log like this, I'm looking for the log of, you get log of 100. Get log of 100, so I'll simply say log, then put 100, and I'll see something like this. That's log of 100. Then I say equals to, what will it be? The calculator tells me that log of 100 is 2. You get it? So that means that our calculators work in decimal bases. Our calculators work in decimal base. So when I get the log of 100, it will be the same as 2. Now using your calculators, find for me Using your calculator, you find for me log of, what is log of 5 according to your calculator? Log of 5, what does it give you?
0.698.
0.6990.
0.7.
0.6990.
0.698970004.
0.70.
What
Yeah,
about
0.
what about
699970004.
log of 4?
0.6989.
0.602 0599991.
0.60205991.
0.6021.
So something like that. You see, that's how we use the calculator to find logarithms. Somebody says, okay, somebody has given me the answer here, 0.69 that. Yeah, so that's what we get when you
Excuse me, teacher.
yes, please.
On the log of 4, the 9s are 3.
There are 3, eh?
Yes.
0.02059991.
That. Okay, so that's how we use our calculator to find logarithms. Now I say, if the base is not indicated, then you're always dealing with a decimal base or a base 10. I think we've understood that. Someone say, should we round off? Yes, they will tell you they want you to round off. If they want you to round off, they will tell you round off to 3 dps, 4 dps. But here, since we're learning, we're just writing everything the way it's appearing. But if they want you to round off, you always round off. Now let's have this example here. Example. Write the following in logarithmic notation.
Excuse me, mister.
Yes, please.
Shall we writing?
No, you're not. I'll send you the work and you write. Now being online and you're writing, that will take us some time.
Log 8 out.
You want to write?
No.
No.
Later.
No.
Later.
No.
Later.
I'll send you the work.
No.
Oh, just explain for us.
Okay. Nothing is write the following in logarithmic notation. They have given you something index notation. How do you write this in terms of logarithm? We just learned that up there when I was explaining the definition of logarithm. How do you write this?
Log 8
can't see
to
the
the
question.
base
Log
2 is
8 to
3.
base 2 is equal to
3.
3.
Yeah. What about this one?
Log 8
Log 27.
Log 27
Log
to the base
27.
3 is 3. Base 3 is 3.
Log 27. This is log. This is log 27 to base 3 equals to 3. Yeah. Hey, what about this one?
Log q
Log
to the
q
base
to the
a
base
is equal to
is equal
p.
to
Equal to P.
Log q to the base a is equal to p.
Perfect. So I think we mastered it. Even if we stopped there today, we have gotten the definition of logarithm. When you understand this, all the other things in logarithm will be very easy. Then what about this one? How do we write them in index notation? We have logarithms. Let's write them in index notation. How do you write them?
2 to the power 2 equals 4.
What does this give us?
2 to the power
2
2 equals
squared
4.
equals 4.
This one is 4 squared equals to 2. This one was written wrongly. I didn't write it properly. This is not possible. This one's supposed to be 2. Oh, sorry. Sorry, just a moment. We have log at the base of 2 of 4 equals to 2. How do you write this? How do you write this in index notation in terms of powers without logarithms?
2
2 to the power 2 to the power 2
2
squared
squared
is 4.
equals
Yeah,
4.
2 squared.
4.
4 equals
Yes.
4.
What about
to
this?
the power
10 to the power 1 equals 10.
that's what
8
1 to
10 to the
1
power
to
10
1
to the
equals
power
10.
1
10 to
1
the
to
power
power
1 is
10 is
10.
equal to 10.
1 power 10 is 1. 10 to the
1
power.
power 10 is 1.
No,
10 to the power 1.
10 to the power
10.
1
No, 1
10
to
to
1
the
power
power 1
10.
is equal to 10.
is equals to 10. Perfect.
Is equal to 10.
Oh,
You have repeated it
Yeah,
lower.
let me just edit
Yes,
this
teacher.
slightly. I make this one put 6 zeros, and I come here. What will be the answer here, even if I don't put it? 10 to the power 10,000.
10 to the power
Is equal.
What's supposed to be here?
100.
10 to the power 4 is equal to 10,000.
10 to the power 4 is equal to 10 is equal to 10,000, and that is it. 10,000, like that.
Yes.
So that is indices. We've learned how to write a number given in index form in logarithm form. We've also written logarithms in index form. Index form, in logarithm form, and logarithm form in index form. That's what we've learned so far. Now the next thing I want us to do is, let me see this one here, log, if they say, number 4 here, log to the power of, this is power 4, this is a half, equals to x. Log of 4 to base a quarter equals x. How do you write this also? How do you write this? You're not seeing it well?
You do not see it well. It's smudged.
Let me write it properly. This is base a half. This is 4. Is log of 4 base a half equals to x. How do you write this?
Half to the power
Half
x
to
equals
power
4.
The power x is equal to
Sorry,
4.
can I have one person who's clear?
half to
Half
power
to
x
power x is equal to 4.
A half power x.
half to the power x is equal to 4.
Yes, I have said it.
How do you find, if they ask you to find the value of x here, what would be the value of x? Can you now apply the indices to find the value of x here? Who can tell us what the value of x will be in this case? Who can tell us what the value of x will be using the knowledge we acquired from indices?
-2.
X equals to -2. Yo, that is perfect. Let's see here. Of course, this will be 2 to the power of -1 into x. When you take these two up, it has a power 1 here. When it goes up, it becomes -1, equals to 4. So 2 to the power of -x is equals to 2 to the power of 2. Now here, when you put the powers, you get x as -2. This is very okay. Very okay. So next thing we want to look at is how we can evaluate logarithms. So I'm going to write the questions here. I prefer typing them, but let me just write them. So the knowledge of knowing how to convert logarithms to index form and converting index form to logarithms can help us to evaluate logarithms. The next element we're looking at here is evaluating logarithms. Evaluating logarithms. You can be asked to evaluate a logarithm, and we use that concept. Let's have examples here. Examples. They can say evaluate Roman number 1 log of 27, log of 9, like that. They can ask you to find the value of that. How do you find the log of this? Does somebody have, is there anybody with an idea on how we can evaluate this number here? They're asking you to find this log. Find the log of 9 root 3 base 27. How can you answer such a question? To which power should we raise 27? To which power should we raise 27 to get 9 root 3? We are going to use the knowledge of converting this in index form. We convert this to indices, then use the knowledge of indices to answer this question. So we shall say, let the power be x. Let the power be x. We're using now the knowledge of conversions, converting logarithm to index form to solve this. They want us to find the log of this, but of course, if it was like log of 2 to the power 8, this one we know it already. It is very obvious. But now, what about this one here? What do we do to evaluate this logarithm? So here, what we do is we assume the power. Since the power, we're looking for the power. We're looking for the log. Which log we know it is a power of 27. So here we're simply saying, let the power be x. So that we shall have the log of 9 root 3 base 27 will be the same as x. Now we've already learned that here 27 to power x will be the same as that. 27 to the power of x is equivalent to 9 root of 3, like that. Are we together up that point?
No.
Yes.
No.
No.
So the question here is saying evaluate log of 9 root 3 to base 27. Evaluate log of this to base 27. Okay, let's first change this to a number more direct, so that I don't bring in the roots very fast. Let's say evaluate log of 1.5 to base 5. What would the log there be? Logarithm of 25, 125 to base 5. What will it be? Now here, of course, we know already this, but you can say let the log be x. Now here we shall have log of 125 to base 5 being equivalent to x. You're simply saying 5 to power x is the same as 125, but you're looking for the logarithm. We're looking for this log here. If they say evaluate, they want you to find the value of all of this, the log of 125 base 5. Now here what we shall do, of course, we shall now say 5 to power x is equals to 125, like that. Then we prime factorize 125. We shall say 5 power x, of course, 125 is the same by 5. It is 25 by 5 will be the same as 5. This will be the same as 5 cubed. That means that here, 5 power x will be the same as 5 cubed. Where there is 125, we put there 5 cubed. So from here, we can simply say x is equal to 3. So therefore, we conclude that the log of 125 to base 5 is the same as 3. That clear now?
Yes.
Yeah, if that's okay, then we can go back now to our question that we had at first. In our question, they're saying evaluate log of 9 root 3 base 27. They want you to find the value of that. They want you to find the index, this index here, that's logarithm. So what we do, let the log be x. Or y, you can say let it be p, let it be w, let it be n later. Here we're saying let it be x. Now here I'll have log of 27, log of 9 root 3 base 27 is equals to x. We are simply saying 27 to the power of x is the same as 9 root of 3. Now here we're solving, we go back to indices. How do we find the value of x here? How do I find the value of x? What do I do? I'll simply express all the sides in terms of their prime factors. Here, you see that this is a prime factor, this is a prime factor, this is a prime number, this is a prime number. So even here, we should do the same. Express them in terms of their prime factors. 9 is the same as 3 squared. And you know that the root of 3 is the same as 3 to the power half. 27 is the same as 3 cubed. So I'm going to substitute everywhere I see that. So I'll have 3 cubed here. Outside I have x equals to 3 squared. And this one times, of course, we're multiplying, times 3 to the power half, like that. So I'll have, we expressed every number here in terms of its prime factors. So we shall have 3 power 3x. Remember, we're looking for the value of x equals to 3 to the power 2 plus a half. So I'll have 3 to the power 3x equals to 3. 2 plus a half, what does it give you?
2.5.
2.5.
What is this?
Can you have it as any paper fraction? To be 5 out of 2, isn't it? Like that.
Yes. 5 out of 2.
Then you equate, since the bases are the same, we couldn't equate the bases from here because even we don't have common bases. You cannot do anything at this point. You have first express them in terms of common bases, then you equate the bases. Now here we have 3, here we have 3. What you do, you equate the powers. 3x will be the same as 5 out of 6, out of 2. Then you divide by 2 on both sides, 3. We shall have x equals to 5 out of 2 divided by 3, which will be the same as x equals to 5 out of 2 times 1 out of 3. This x will be the same as 5 out of 6, like that. So therefore, you found your value of x. Here you can now say that your log, you can now say that your log, I've even crossed it instead. You can now say that log of 9 root of 3 to 9 root of 3 to base 27 is the same as 5 out of 6, like that. That's how we use that concept to evaluate logarithms. Do you have any question from there?
Excuse me, teacher.
Yes, please.
I've not understood that part of 3 to the power 3 into x is equal to 3 squared times 3 to the power a half.
Okay. Did you
Then to continue.
Did you understand this part here? This one. This one?
Teacher, which one?
The one I've circled in red.
Yes.
Now here we have 5 power x equals to 1.5. You notice that the bases are not the same, but this 1.5 can be in some way expressed in terms of 5. We wrote it as 5 cubed. Now even here, we are looking for x. We are looking for this x. But notice that the bases are not the same, so we can't do anything unless the bases have been expressed in terms of the same factors. So what I do here is I break down the 27 expressed in terms of 3, which is this. I also break down the 9 expressed in terms of 3 squared. Then I also write the 3 power half, 3, the root of 3 in terms of this. So here I'm just substituting. This comes there. This is the same as that. This is the same as that. And this is the same as that. My endeavor here is to have both sides expressed in terms of the same factor, the same base, so that I can equate the powers. That's what I'm trying to do there. So making the bases the same so that I equate the powers. So 27 is 3 cubed. Then the x is outside, it is here. This x is here. Then this root is, these are half there. That's what we're trying to do there. Is it clear now?
Yes. Also, the working, when it goes on, 3 to the power 3x is equal to 3 to the power 2 plus a half.
Yes. Here we are applying the laws of indices. I think you missed the first sessions of indices. Did you?
Yeah.
Yeah.
I think I missed.
That's what the toilet is. So here, the law of indices says if you're multiplying numbers of the same base, you're multiplying numbers of the same base, add the powers. You add the powers. So here we're multiplying 3 times 3, bases are the same, we add the power. Then here, 3 is equal to 3, 3 power 3x is equal to 3 power 5 out of 2. So if the bases are the same, then the powers should also be the same. That's why we're equating 3x equals 5 out of 2. Then here we divided by 3 on both sides, and we ended up with x equals 5 out of 6. That's that answer.
Yes.
But then maybe to help you more, I'll send you the video. I'll send a video of the previous lessons so that you can follow it and catch up with your colleagues.
Yes, thank you, teacher.
Somebody raised their hand. I think I forgot to check on him. Somebody has a hand up. I don't see it anymore. Okay, let's proceed. Let's have another trial here. They can say log, example 2. This is example 1, this is example 2. Let's go to example 3. Hello, mute yourself. Hello, mute yourselves.
Must be fed.
Okay. So the other one is log of a half. I mean log of a quarter. Log of a quarter base a half. This is the number whose logarithm you're looking for. This is the base. Now, how do you do this? Just follow the same procedure. We're looking for the log of this. We're looking for the value to which a half should be raised so that we get a quarter. Which value should which power should a half be raised to so that we get a quarter? So here we shall say, let log of a half, log of a quarter base a half be the same as x. Now this would mean, if you learn the other conversion, this would mean that a half power x is equals to a quarter. A half to the power of x should be equivalent to a quarter. Then our endeavor again is make sure we have the same bases, expressing this in terms of the same bases. Just a moment, let me come and proceed. Let me come. Just like indices, logarithms, there are also laws of logarithms. So laws Laws of logarithms. That's what we're looking at next, the laws of logarithms. Those are the laws we're going to base on to do most of the numbers that will follow. Just like we use the laws of indices to do most of the numbers. What is this? Laws of logarithms.
Yes, Munira, you're raising your hand.
You've written last.
You have missed the laws.
There are laws.
Laws of logarithms.
Of
You can see the pigs, eh? Okay.
Of logarithms. Like that.
Product law.
Laws of logarithms. Now, what are some of the laws that we need to, we may not prove them, but the very obvious one that you can see is, we said, what does, number one, what does log of 10 base 10 give us? What will it give us?
1.
1. Perfect. So the very first law says, log of any number to the base of the same number must give us 1. So now I find maybe log of 10 base 10, log of 2 base 2, log of 3 base 3, log of 4 base 4. It will always give us 1. That will always give us 1. Because 1, any number raised to the power of 1 will always remain the same number. I think you know that. So this is the first law that we're looking at. And we've seen that from the previous work. Then the other one is, let me get the second one. Let me see here. Let me stop the share shortly and I come back.
Hello? Can you see?
A moment, there's something I'm working on here.
Hello? You cannot see the desktop.
Who is that?
A moment. Okay. Let me see what has happened here. What is going on? Okay. I think things have gone back to normal. Yes, screen. Okay. This is one of it. Then the other one is the power law. The power law. The power law, what does it say? If you're finding log, let's admit, log of, I'm just giving you an example here. See the waiting room. People are moving up and down. You're going to miss out the concept. You mix out the concept. So we said, let's pay attention here. If we have log of 100 to base 10, what does this give us?
10. Oh, 2.
Gives us 2, isn't it?
2.
But then this can also be written as log to base 10 of what? 10 squared. You see that? This becomes again a longer thing. We have, because 100 is the same as 10 squared. So this is log of 10 squared to base 10. And we're saying this is still the same as 2. But somewhere in the first law, we said if you have log of 10 to base 10 is the same as 1. So this can also be the same as, you can also see it as log, as when this 2 comes this way. When that 2 comes this way, we shall have 2 log
AM.
Log 10, 10, isn't
Log
it?
base 10.
Log 10, 10. But you know log 10, 10 is the same as 1, isn't it?
1.
So this is the same as 2 times 1, because log 10, 10 is the same as 1, which gives us 2. So this takes us to some other law called the power law. The power law says if you have log, if you're looking for log of any number, let's say p squared, or pit power, let me say pit power. Let's say pit power, not 2 again. Let me just say power. Let's say power x to base q. When you have, when you're looking for log of p power x to base q, you see here we're looking for log of 10 base 10 power 2. So we dropped the 2, we brought the 2 this side. So even here we can take this x this side like that, and we shall end up with x log of p base q. That's what the power law says. Power law says if you have looking for the log of a number, but that number has a power of it, you can drop that power and proceed. Example here, you can say log of 8 base 2. Log of 8 base 2. 8 is the same as 8
The power 3.
to the power 3. So here where it is 8, I'm going to put 2 power 3. So this is the same as log of 2 power 3, and here we have 2. But then we can remove this 3 and it comes this way. So we shall end up with 3 log of 2 base 2. But you know this is 1. Log of a number to its own base.
3 times 1.
So this is 3 times 1. And that gives you 3. So what you should also know, that's the second.
Teacher, can you help me with the therapy examples you gave?
With? I'll give you another example. Hello?
Can you please repeat for me the examples?
Examples, you know?
Not the working, just the examples.
On laws of logarithm, eh? Hello?
Yes.
Yeah. From the first law. From the first law, we're saying the first law is log of a base a is the same as 1. And this will be the same as log of b base b to also be the same as 1, like that.
Yes.
Yeah. So we say, I think you understood this one, isn't it? Did you understand it? What we're saying, if I have log of 10 base 10, we're simply saying 10 to power 1 is the same as 10. Any number to log of any number to its own base, the same base, is the same as 1. We looked at that in the previous example we just done. Log of any number to its own base, the same base, has to be 1, because 10 to the power of 1 will give me 10. A to the power of 1 will be the same as A. So the law says if you have a number, log of a number to the same base, the base being the same as a number, you must get 1. That's the first law of logarithms that we're dealing with. First law is that one. Then the second law, we're deriving it from this argument. We're saying that if you're looking for the log of 100, log of 100 base 10, what did it give you? Log of 100 base 10 is the same as 2. Log of 100 base 10 is the same as 2. But then we've just looked at the first law here. We're trying to express this in terms of the first law. 100 is the same as 10 squared. 100 is the same as 10 squared. So I write log of 100, log of 10 squared base 10 is the same as 2. This one here is the same as 100. So if I carry out these two, I bring it this side. I bring these two this side. Our main is log 10, 10. Log of 10 base 10. But know that log of 10, 10 is the same as 1. Any number, if you're finding the log and the number is the same as the base, then that will be the same as 1. That's why you have this 1 here. The whole of this one here has given us this 1, that one. So 2 times 1 gives us 1, which is in line with even what we got at first. So it is from this that we're deriving our law. We're saying if you're finding log of a number to raise to a power to base q, then it is fine. It is very okay for you to carry out that number, carry it away, put it here, and remain with this. That's what the law says. And I am again demonstrating it using this one. Log of 8 base 2. 8 is the same as 2 cubed. So this will be the same as log of 2 cubed base 2. I carry out this, I carry away this. My endeavor is to have log of a number that is the same as the base, to have the base and the number being the same. That's my endeavor here. So I carry away the 3, I'll be left with this. So that means that you have 3 log 2, 2, but then this is the same as 1. So therefore, I'll be left with 3 as the answer. And which is in line with what we know already. Log of 8 base 2 is obviously the same as 3. 2 to the power of 3 will give me 8. But this is now just like the working. We're using the law of logarithm to answer that question. Does that make you understand it now?
Yes. Yes, teacher.
Okay. Yeah. So we've looked at 2 laws so far. The first one, the second one is this one.
Not yet. Not yet.
Sorry? Somebody is saying not yet. What is the issue so that we polish it up? What is the issue there so that we handle it before we proceed?
Excuse me, teacher.
Yes, please.
The
power law.
The power law.
The log for the second one. Yes. Is the answer is 2? What's the answer?
Which one?
The second one. Of the power law, the example of power law.
This one here.
Yeah.
Okay, let me clear it and we derive it again afresh. Now, these are the things you should understand because math, like I've been telling your colleague, math is cumulative in such a way that one concept leads to the other, one concept leads to the other, one level leads to another level. Primary mathematics works as the backbone for secondary mathematics. Secondary mathematics, senior 1 works for senior 2, senior 2 works for senior 3. One topic leads to the other. So if you don't understand a concept in one topic, it may become a problem for you somewhere else. Like we started with indices, I said indices is applied in logarithm, and you see indices is coming back here. So if you have issues with indices, then you need to polish it up. This logarithm here, is this just the beginning? You're going to deal with logarithm almost for the rest of your math life. So you need to understand it very well. So the law says if you're finding log, this is what the law is. Log of any number, let's say p, raised to the power of x to base q. This is as good as dropping this x this way, writing x this way, and then you write log of p base q, just like that. And I was proving it using this. I was saying, if you have maybe some illustration here or example, if you're looking for the log of, let's say, 100 to base 10, we already know that this answer is 2. But how can I use the knowledge? How can I use this law to come up with the 2? I'll say this is the same as log of 10 squared, because 100 is the same as 10 squared. 10 squared base 10. Now, according to this law, I'm supposed to drop the 2. So this will be the same as 2 log of 10 base 10. And what does this give me? From the first law, we know that log of 10 base 10 should give us 1. You try using your calculator. For those with calculators, get log of 10, because our calculators already work in base 10. So you try using your calculator and find the log of 10. And
1.
It gives you 1, isn't it? And we already know from the first law it is 1, because 10 to the power 1 gives me 10. So this will be the same as 2 times 1. And the answer will be 2. So using this law, I can see that log of 100 base 10 is the same as 2. But of course, you can also use the indices that we covered earlier. Just say 10 to the power of 2 is the same as 100, like that. Or we can use this argument. The other example I gave you here is when you have log of, let's say log of 8 base 2. This is the same as log of 2 cubed base 2. I can remove this one, drop it this way. I'll be left with 3 log of 2 base 2. And this will be the same as 3 times 1, and like that. Now, there are some numbers. Let's say you're looking for the log of 9 base 2, something like this. This will be the same as log of 3 squared base 2, like this. When I drop the 2, I'll have 2 log of 3 base 2. Now this one doesn't give me 1. I can't do anything about this. I just stop there. There's nothing much I can do about this, because much as I've dropped the power, there's no relationship between 3 and 4. No, they're not the same. I can't say it is 1. I can't say it's anything, because I don't have any idea about it. To which power should I raise 2 so that I get 3? That power is not very obvious, you know, not very obvious. So that's where I stop. That's where I stop for that case. Is that clear now?
Yes.
Okay. That's now the second law. I just want to introduce these laws so that we apply them in the next lesson. There are 2 more laws left. The third law is the law of addition. Law of addition. The law of addition. This law says, if you're having maybe log of p times q to base a, something like that. If you're finding log of p times q to base a, then this is the same as log, since the base is the same, we are multiplying this. Since the bases are the same, this is the same as log of, this is the same as log of p to base a plus log of q to base a. So if you're multiplying p times q, if it is p times q, what do? We add. The reverse is also true. If I'm adding 2 logarithms, then it's the same as multiplying. I just multiply them the same base. If you're adding 2 logarithms to the same base, what do you do to the powers? Or what do you do to the logarithms? You simply add them. I mean multiply them. You're adding here, you multiply. You remember the law of indices where we said if you're multiplying 2 values, let's say A and this is B, you add. You add their powers. So even here, when you multiply, remember these are powers. Logs are powers. So if you're adding powers, then it means that you can just multiply the logs like this. See, this log and plus that log. Here we simply get this. That's what the law says. Example, here we can say, example, if you're finding log of maybe this is 2 and this is 8 times 5, like that. This will be the same as log of 8 base 2 plus log of 5 base 2, like that. That's what the law says. And the reverse is true. Also, if I'm having, that's example 1. Example 2, if you have log of, let's say, if you have log of, let's say, 4 base 3 plus log of maybe 8 base 3. This is the same as getting the log. Since the bases are the same, you know that the base here is the same as the base there. This is the same as finding log to base 3 of 4 times 8. I can simply multiply the power. Since I'm adding and they have the same base, so this becomes log of 32 to base 3, something like that. We're just getting the laws of indices. So if you don't understand the law, you can ask. I'm trying to demonstrate these laws using the examples.
Teacher.
Yes, please.
If you're able to multiply log 4 times 8, which means also on the first example, you also multiply.
This now example 1.
Yes.
Yeah. Yes, if you multiply to bring you back.
Yes.
I can bring it back and say this is the same as
yes.
log. Yeah, of what? 8 times 5, like that. You can multiply them and you get 40, but I was just demonstrating a law. You know, you can multiply them and get 40, but I was just.
Can you give that as the answer?
Which one? Yeah, of course, this becomes log.
Although,
you can say log of 2 log of 40 base 2, something like that. I'm just showing you what you do with the laws. If you're multiplying 2 terms, log of 8 times 5, what is it equivalent to if you want to use the law of logarithm? You can add, say log of 8 base 2 plus log of 5 base 2. This is very fine. These two are equivalent. They're equal to one another. Is that okay?
Yes.
So we're just learning,
yes.
learning how to use the laws. Then the very last law, law 4, is the law of subtraction. The law of subtraction. Now the law of subtraction says, if you're dividing the terms, log of P out of Q, something like this, to base, let's say base A. If you're dividing like this, then you're going to subtract. This will be the same as log of P base A minus log of Q base A, like that. So if you're dividing the logs, you subtract them here. If I'm dividing here like this, I'm going to subtract. And the reverse is also true. When I'm subtracting, I divide. Is that okay?
Yes, sir.
Okay. So in the next lesson, we shall look at examples. Seriously, we shall look at detailed examples on that. And also, we shall do more examples on this next time. And I think we shall stop there for today. Chimera has a hand up. Yes, Chimera?
Teacher, I'm sorry, but I don't really understand example 1. It's like you're saying, what? 8 times 5, then you say log 8 plus log 5. Then you change it back to 8 times. So what was the use of?
I was explaining something for somebody. Okay, let me remove it and explain it better, or use another illustration.
Okay.
So here we're saying, they can say, okay, the question will be, express this as a single logarithm. They can say express as a single logarithm. A single logarithm. So they'll say maybe log of 3 base 2 plus log of maybe 4 base 2, something like that. This will be the same as log of log of 3 times 2, times 4 to base 2, like that. And this will give us log of 12 base 2, something like that. Now, just like this, they can also give you one that is single and ask you to separate. They can say, if log of 3 maybe to base 2 is something, they give you the answer. Then also log of maybe 5 to base 2. I'm just avoiding bringing in the detailed examples because we are just deriving the. They also give you the answer for that. They give you log of 3. They also give you log of 5. Then they can say, find the log of 15 to base 2, something like this. This is what we're going. This is where we're going to apply this concept. We know that 15 is the same as 3 times 5. So this is the same as log of 3 times 5 to base 2, which will be the same as, now using the law. The law says if you're multiplying, you add the log. So this will be log of 3 base 2 plus log of 5 base 2. They will have given you those values here already, so just come and substitute them in and get the answer. But I didn't want to bring in this such detailed questions. But I separate.
You, teacher.
You're welcome. So I think I'll stop there for class. Next time we meet.
Chobu, relax.
Chobu, pass me.
They are bouncing the job.
But your hand is up.
You can complain.
Chimera, your hand is up. Chimera.
I was asking.
Yes, please.
Where can you get the recording for the?
I'm going to share it with you. I'll put it on the YouTube channel, but after putting, I'll send the link to the group, so you get it from there. I'll send the link there, so just click on it because I have other videos on the channel. So I'll simply put the link on the group, and you'll find it. You connect straight to the video. I'm going to give you this video. Then another one. There's another hand still up. That is Elijah. Elijah, your hand is up. Okay, so that is logarithm for us. We shall do more next time. I'll send you the link for the video. Then I'll also send you the notes. Send you the notes and you work it out. All right, have a nice time. See you in the next lesson.
Thank you, teacher.
Bye. You're welcome.
Yeah, thank you.
You're welcome.
Thank you for the lesson.
Hey, Chobu. Thank you, teacher.
You're welcome.
Chobu.
Hey, Chobu.
One by the tires. Nara.